Yes, so let's move on to the seventh property, which is differentiation in time domain. So what does it say? If x of t has x of j omega as the Fourier transform, then d by dt of x of t will have j omega into x of j omega as the Fourier transform. So this is easy to prove. So we will take proof here. Okay, so let us take the help of synthesis equation. So synthesis equation. Okay, so according to synthesis equation, what do we get? We get x of t is equal to 1 by 2 pi integral minus infinity to infinity x of j omega multiplied with e power j omega t d omega, correct? So this is our synthesis equation. So next what we will do is we differentiate this. So this implies, so differentiate with respect to time, correct? So d by dt of x of t would be equal to how much here? 1 by 2 pi integral minus infinity to infinity. No need to differentiate x of j omega, correct? So that would be x of j omega multiplied with differentiation of e power j omega t should be j omega times e power j omega t d omega. Okay, so this should be equal to how much? 1 by 2 pi integral minus infinity to infinity j omega x of j omega multiplied with e power j omega t d omega. So that would be the differentiation of x of t. But if you look at this a little bit carefully, how is this looking at? So j omega into x of j omega, we can write it as some x1 of j omega because it is some function of omega. So this whole integral is seen as 1 by 2 pi integral minus infinity to infinity x1 of j omega multiplied with e power j omega t d omega. Means what? This is inverse Fourier transform of which signal? X1 of j omega, and that is equal to how much? Derivative of x of t. But what is x1 of j omega? It is j omega times x of j omega. So definitely it means what? D by dt of x of t is inverse Fourier transform of j omega times x of j omega, or d by dt of x of t will have j omega multiplied with x of j omega as the Fourier transform. Okay, so we can generalize this. What do I mean by that? Generally means I differentiate this n times. So d power n x of t divided by dt power n will have, if you differentiate once you will get j omega, if you differentiate n times you will get j omega whole power n multiplied with x of j omega. So that would be the Fourier transform of nth derivative of x of t. Okay, but here we should be a little bit careful. So what do I mean by that is that we will take a note. Okay, so what is that? For any not even aperiodic, any for any signal x of t, you write like that. So for any signal x of t, average value. Okay, so average value is given by, for any signal x of t, average value is given by, okay, I'll write down as avg of x, or I'll just say ax. Okay, ax would be right, or we'll take avgx. Okay, that should be equal to limit t1 tends to infinity 1 by 2 t1 integral minus t1 to plus t1 x of t dt. Okay, this is a way how we define the average value of a signal. Okay, even for periodic signal the same rule applies. Okay, so but for periodic signal t would be the period and this limit will not be there. Okay, is that okay? So for periodic signal there won't be limit, and t1 is same as period of the signal x of t. But in general, for any signal x of t, average value is defined like this. Okay, so differentiation in time domain property. Okay, we can differentiation in time domain property can be used only when property can be directly used. Okay, can be directly used only if the average value of the signal is 0. Okay, only if average value of the signal is 0, then we can use differentiation in time domain property directly. So you can use differentiation in time domain property. For example, what do I mean by that is, for example, if the average value of the signal is not 0, then can we use differentiation in time domain property directly? No. So there is indirect way of finding the Fourier transform of that kind of signal, but we are not going to see that one. Okay, so that involves little bit of higher mathematics called generalized functions, which is actually out of syllabus for us. Okay, so when can we apply differentiation in time domain property here? Only if the average value of the signal is 0. If it is not 0, then we cannot apply differentiation in time domain property directly. Okay, directly means just differentiation. That will not help, that will not give you the right answer. Okay,